Good morning, good afternoon, good evening.
Good morning, Kendall. Good morning,
How are
all.
you doing?
I'm good, Kendall.
Good.
Hello all, morning.
Well, good morning.
Hello.
Hello Gulmi, how are you?
Good, and you?
That's nice. Hello Kendall.
Hello. How are you doing, Parthaban?
Good Kendall.
Good. We'll just give it another minute or two, get some more people on, and then we'll get started.
Sure, Kendall.
All right, looks like we're getting a few more people here. So let's go ahead and get started. We'll actually start our meeting off a little differently. We're going to start with Guillaume. He's going to give, well, I'll just let you kick it off and tell us what you're presenting.
Okay, perfect. So hello, everybody. For those who don't know me, I'm Guillaume. I'm engineering manager for telco here at Canonical. And here I want to do a demo. And let me share my screen here. All right. So the idea of the demo, ultimately, it will be to deploy Orchestrator using Juju. All right. So I'll do just that. And then while it is deploying, I'll be explaining ultimately like what it is that's happening behind the scenes. So for the purpose of this demo, I'll be deploying it on GKE. And that is one of the interesting pieces of using Juju for our cases is that, well, you don't have to use it on AWS or any other specific K8s cluster. Ultimately, Juju doesn't really care. But so here we'll be deploying Orchestrator on GKE using Juju. All right. So do you see my screen and my Google Cloud page?
Yep.
Yeah.
Yeah. Awesome. Perfect. All right. So here I have a cluster on the Google Cloud, and there should be nothing at all running in it. So it's pretty empty. All right. So here I'll make sure I can connect to it. And now I'm on my terminal. And I can do kubectl commands, and I can get my nodes. All right. So that's the first part. So I have a K8s cluster on GKE. I can connect to it. Now, first thing will be to add this new cluster to our Juju CLI. And by the way, everything I'm saying here that maybe you don't understand, I'll try to explain that like I said earlier while it is deploying. So for now, I'll just do things, and it's fine if you don't understand everything. So I'll add K8s, and we'll have to give it a name. So let's call them, I don't know, demo. Oops, I already have something that's called demo. Let's call it demo 2. All right, and here I'm going to bootstrap demo 2. And what that means ultimately is that we're going to create a Juju controller inside of our K8s cluster. So this controller ultimately is responsible, acts as like a management node for our environment, for our cluster. So whenever any type of event is going to occur, this controller is going to be responsible for sending them to our different applications. And by bootstrapping it, ultimately what it means is simply what we do is we create a pod on our cluster for controllers. That's why it takes a bit of time. But now if I go back to my K8s cluster here, we see the controller is being deployed, and it should take a couple more seconds. So pods are pending. And once it is deployed, we're going to be able to deploy our application. All right, so it should be fairly soon. And here, by the way, we are deploying a Magma orchestrator, but we could be deploying any application. The controller doesn't care at all. And we have there are tons of other applications that you can deploy using Juju. For example, you could deploy a Postgres database. You could deploy Mattermost. You could deploy ultimately tons of different applications. But here we'll use it for Magma. All right. So now what we're going to do is we're going to add a new model. And in the context of Kubernetes, this new model is a new namespace. So we'll call it demo. All right. So we have a cluster, we have a controller, and we have a new namespace inside of this cluster. So now we're ready to deploy Magma orchestrator. So that's exactly what I'm going to do. To deploy it, we're going to need to specify what is the domain name that we want for application. And that domain name is going to be inside of a what we call a overlay file. Because Magma itself is not just an application, it is a list of applications. We need to have this file to specify some sort of specific configurations. Here I already have it, so it only contains my domain name. And I'm going to deploy Juju deploy Magma orchestrator. I need to specify that we take this application from the edge channel, because right now our application is not like very much ready to be used by actual customers, so it's only available on edge. But in the future, you'll be able to ignore the edge part. We also need to specify that we want to use this overlay file. And we also need to specify that we trust it. And that should be good enough. All right. So like I mentioned, Magma orchestrator itself is not just one service or one application. It's a set of 25, 26 services and applications that are being deployed. So what is happening now is that all of those different components are being retrieved from Charm Hub, so the store of charms, the store of applications, and they're going to be deployed on Kubernetes. So now I think is the part where I need to explain exactly what's happening behind the scenes, because there might be some questions. All right, so let me, that's not a good presentation. All right, here. So let me spend some time explaining what is happening here. So what is Juju? So Juju is a free open source application management and automation software. So if you're running a Ubuntu machine, all you need to do is snap install Juju. So it just works. Its purpose is to deploy, integrate, and manage K8s, container, and VMnet native application. So in our case, it's really K8s applications, but note that Juju can also deploy other types of application. And the main reason why it is interesting to use Juju is to drive operations. And by operations, I mean those operations could be upgrade operations. If you want to scale, if you want to relate to applications. So different types of, if you want to configure it as well. So different types of operations that you might want to do. Now, instead of those operations being stored inside of maybe scripts that you have inside of your company or inside of the head of some of your developers, now all those operations are coded inside of Python code. And that's the main reason why people use charms, is because you package your application and your operations code together. And here, when you do a Juju deploy of your applications, you have both the operation code and the actual like workload. So if you deploy PostgreSQL, well, what you are doing is both deploying PostgreSQL and also you have access to different type of operations code. Now, how it works in the background is that, so here I was launching the commands from my laptop. So you have the Juju CLI that's running on my laptop. And like I mentioned, we deployed a controller. So that controller is an actual pod that exists on Kubernetes. And this controller is going to deploy both your workload and the charm. And the charm itself contains the operations code. So I was talking about code to drive the operation. So this is actual Python code, and I'll be able to show that later to you. And this code is going to contain logic. So whenever this event occurs, I take those actions. So if we're talking about magma service, for example, when there could be, so whenever I'm connected to the database, I want to start my service. So any type of operation related to different events can be stored here. And the most important type of operations that we will work on, and we haven't yet done it, is concerning upgrades. So it will make it really like seamless to upgrade your application. So yeah, so in the context of orchestrator now, so orchestrator is a big thing. So like I said, there's 20 something services. So what happens behind the scene when you do Juju deploy magma orchestrator is you deploy each of those charms. So a package of both the workload and the operations code for each of those applications. What we see here, we also see arrows between some of those charms. And those arrows, they represent relationships. So I haven't yet introduced relationship, and I don't want to spend too much time on like the details of it. But the idea of relationships ultimately is that they contain data that can be used, that an application needs, and that is given by another application. So if we talk about PostgreSQL, for example, that we have in the bottom here, well, if you take a service like device, for example, well, device requires information from the database. It requires its URL, its username and password. So this information is stored inside of a relationship that device can access and use. But all of this is abstracted to the user. Like all you have to do is to Juju deploy your application. Like all I'm saying here is like explaining what happens behind the scene, but the content of those relationships doesn't have to be known by a user. So yeah, now I'll go back to the application and look at the state. To look at the state of your deployment, you just do a Juju status. So it's still pending, like it takes a bit of time. So here, what we see here, we see that, well, on the left, we have all of our applications, and that some of them are waiting for the PostgreSQL K8s service to be running, because they need to be related to it. So they're waiting for database relation to be established. We can also look at, we can also use our kube command. So the namespace we created is called demo. So here we see all of our pods are either running or pending. What else we can look at? We can look at services. And those should be very much similar to what you would have whenever you deploy orchestrator on AWS or anywhere else. Now, while it is still, the deployment is still pending, what I'm gonna do is I'm gonna configure my Google domain to use the different load balancer addresses that were created. So Here, if I go back to my cluster inside of Google Cloud, and you go to services, you can see that the same services that were accessible through the kube command also show up here. And if we care specifically about load balancer services, so those are the services that we need to have externally accessible, and we can associate them to domain names. So I'll do exactly that. I just need my Google domain. All right, so the domain name I am using right now is called pura.com, and it's an actual domain that I have. And I'll be configuring the various A records for this domain. All right, so for API.myDomain, so this service is associated with this one, so 34.73.186. So let me copy paste that. Now Bootstrapper controller is associated to this one. And finally, controller is client cert. All right, and is that the good one? No. Okay. All right, so now I have my domain names associated with my external load balancer addresses, which means that those addresses are now publicly accessible. So anybody can actually test it if you want on your side. You should be able to access those addresses, and they should resolve to their correct domain name. But before magma needs to be completely deployed, so still pending. What we can do here while it is still pending is to retrieve the certificates that were created. So here we are using self-signed certificates, and those are created inside of the orchestrator certifier charm. So what I'm going to do is I'm going to retrieve those certificates. So there's a command called Juju SCP. So ultimately, it's going to connect to a charm, and it's going to copy a file locally. So now I have my admin operator.pfx file. So I'll import it inside of Google. There we go. All right, so I have imported it, and now I might have to wait still a bit. So yeah, deploying PostgreSQL is the one that takes the most time. So all the others are ready; they're just waiting for this relationship to be established. So any question up to now while we're waiting for this?
Yeah, hey, Game. I have a few questions. One thing is, I don't see Elasticsearch. Do we deploy it?
Yeah. No, good point. So Elasticsearch and FluentD are not yet completed. So I'll explain at the end like where we're at with like our current progress. And like right now, our current focus is really on integrating with logging, monitoring, and alerting. So for monitoring and alerting, it's pretty simple because there's already charms for Prometheus, Grafana, and Alert Manager, and we just integrate with those. They already exist, and we can integrate with those. It's pretty simple. For Elasticsearch, we have charms for low-key. So it's not clear yet how we're going to integrate with Elasticsearch and FluentD, but that's still in progress. Like so, for now, they're not there, but they have to be there for it to be like a complete working solution.
Okay. And another thing, I see you did manually like 6 entries for the DNS.
Yeah.
So there are two things. One, we can use wildcard for the NMS entries. Second thing, we can use external DNS plugin, which will do all the entries for us. This is what we are doing in our AWS setup at the moment.
Okay.
Yeah.
Well,
So
thanks
this
for
we can
that
do.
comment. Let me just so I just took some notes. Okay, it's good to know. Here, ultimately, we're doing pretty much like the same as you would do when you would follow like the official documentation to deploy Magma. So you're they use Route 53 in AWS, and you would have to configure those. But yeah, it's
Also, which version of PostgreSQL we are using?
let me just validate that. It's hard to tell from here. I'll
Check the
come.
tag. Yeah.
I'm sorry.
Just check the tag, image tag. Scroll up. Wait. Okay, this is in it. Oh, no, scroll down. Yeah, I don't see it. Yeah, we'll look into it. Okay.
Yeah, I'll come back to you with the exact version.
Yeah.
All right, so now most of our services are up and running, but not all of them though. So we'll still wait a couple more seconds. And if anybody has questions, you can ask them, by the way.
Yeah. So Gurmeet, this is Parthiban from Wavelab. So using Kubernetes, we could set up an redundancy part with the Magma orchestrator. Did you had any exploration on that area?
And can you repeat, please?
No, making the complete Magma orchestrator redundancy, say the high availability of the Magma orchestrator, say for some reason the entire node goes down.
Yeah. So with Juju, you can create more units of each of those services, and you can also have them like created by default. So whenever I deploy this application, I have multiple units of it. We haven't tested it yet. So for now, it's just one unit of each service, but this can be easily validated. So for now, I don't know if it works, but it should be working.
So when you say about units, you are talking about within the same cluster having multiple units of components to run, services to run, if I understand, correct?
Yeah, but running on different hosts, but in the same cluster, yeah.
Okay. Yeah, running on different hosts on same cluster. What if the entire cluster goes down for some reason? So it's unlikely in a cloud environment. If it is an on-prem, it's possible, right?
Yeah. Well, right now, yeah. So if the whole cluster goes down, right now there's no security for that. There's security for like an individual host going down, but not like a whole infrastructure. Yeah.
Yeah. I'm not sure anybody else have tried this one. Shubham, have you tried any redundancy or high availability of the orchestrator anytime?
Yeah, we have. So what we technically do is that we deploy 3 nodes in different availability like zones. So if let's say entire zone goes down, we will still be having 2 more nodes still running on those availability zones. And if we are using some managed Kubernetes cluster, let's say some EKS or GKS, in that scenario, another node will be spinned up in another availability zone. Then we'll have all our apps up and running. And if let's say in this scenario it is unit, but in normal Kubernetes scenario it will be pods. So in production environment we have 2 pods for every single service. So if pods, let's say one node goes down and pods goes down, and within seconds new pods will be up and running in other 2 availability zones.
Yeah, but it's all feature given out by the Kubernetes, right? But will it make sure to sync up all the configs of AGWs connected to that orchestrator as well?
Yeah. Because that is handled by load balancer. Load balancer is a region-based service. If we have a so in that, even if availability zones are like nodes are going down, if we are using load balancer, our services like that are connected with the access gateway, they won't go down.
Okay, load balancer is something outside Magma, right? That's not part of
Sorry,
Magma.
you mind? I'll just interrupt. I'll just finish the demo, and then we can hop back onto this
Sorry,
this discussion. It's fine. All right. So here, what remains to be done ultimately is to create our orchestrator admin user. So this is done through a Juju action. So the action is called create orchestrator admin user, and then the other action that we have to run is ultimately creating a username and password for NMS. So here, just do that. And this piece in the future can be done all automatically. Just now they're done through actions. All right, so we have our admin user and action created. So now we can go to master.nms.my domain. And it's about the self-signed cert. All right, and there we go. So Magma is up and running. It's working.
Did you set password for the master organization?
Yeah, should be. Let me just look at the logs. Is there any success? So the username and password should be created.
Didn't specify the organization. You just specify the like ID password.
Yeah, but that's should be done by default behind the scenes.
Your username doesn't have the top level domain. It's just admin@example without the .com.
Admin@example.
No, it's not .com. It's just simply like remove the .com.
Oh, okay. You're right. My bad. Okay.
Yeah.
Okay, you're right. All right. So there you go. So we have Magma running. And yeah, I'm not sure at this point what we can do, but oh yeah, what I'm gonna show you is ultimately how we can connect to another organization. Yep, already exists. All right, so there you go. Now there's no networks, but let's say we add one, whatever. So we can create our network. And now there you go. So like we mentioned earlier, the stuff that we're working as of today is integrating with logging, monitoring, and other thing. So these pieces, they're not yet working. So Grafana and so this piece is not yet working, but we're working on it. But ultimately, at this point, you could connect a access gateway to this instance of orchestrator, and it should work. And yeah, in terms of demo, I'm pretty much done. I can spend some time about talking. So what's next? So right now we've developed our charm. We published them. We validated that they work on different like Kubernetes distributions such as MicroK, GKE, EKS, and we're working on integrating with logging, monitoring, and everything. In parallel, we're also working on writing a snap and then a charm for access gateway. So in the future, it should be as simple as you Juju deploy orchestrator, you Juju deploy access gateway, you relate them, and that's it. They should like automatically register one to the other and just work. So yeah, that's pretty much them in terms of demo. Any question?
I just wanted to comment that the snap might be useful by itself if you want to just run the access gateway itself in a simple scenario without an orchestrator. You can use just the snap on Ubuntu, just do snap install access gateway, and then you have it up and running.
The snap will create all the interfaces and configure all the files and everything, right?
Yeah.
That's the goal. Yeah. Great. This is really good.
Yeah. All right. So if there's no other question, like, please feel free to reach out to me if you have some question. And by the way, everything we build is all open source. It's all located inside of those repositories, and you can contribute to those. Feel free to, if you're not sure where to start, you can ask me. It's all open and free. So let me know if you have any question or comments. All right. Thank you.
Thanks, Guillaume. All right, we will now go to our normal updates. We'll start with 5G update. Who will be getting that? Daljit, Parthiban?
Hi, Kendall. I'll try
Awesome.
on that. That's fine.
Sure.
Hi, can you see my screen?
Yes, Daljit, please put it on full screen.
All righty. So
Daljit,
we are working on, yeah, can you hear
your
me?
screen share is, no, your screen share is gone.
Oh, is it? Hold on. Can you see now?
Yes, please go ahead.
Okay. So the team is very much working on testing the release 1.7 features, doing scale testing, regression testing, and we have very much done with the real equipment testing. We have done a whole lot of testing. That part is very much completed, and we are continuing further testing. And from development side, GTP extension header support feature is the only feature which we are still under development, and there are going to be series of features which will come after 1.7 release. Though we are also continuing working on the regression and testing those features. So this is the hardening of the branch. So we have fixed these issues here. The defect got fixed. PDU session retry issue was observed and it's got fixed. We did an enhancement for logging related to authentication failure. And there is a new script for verification of stateless feature added there. So from the peer merge side, there is a re-authentication during subscriber database lock issue that has been merged. Logging enhancement, same issue we talked before. Duplicate session creation response in session D. So this is the sending the status of the duplicate session is being sent to VMF in this case. And there's some federation gateway enhancement to redirect the session request for N7 and 40 proxy. So the feature, this is the list of the feature which already shared with the community for 1.7 from 5G perspective. And the status is continue testing. And as we discussed before, and making sure the release stays stable. We didn't observe any new issue which need to be ported to 1.7. So it looks like good shape so far. This is the extender feature which I was mentioning, which will go in 1.7.x. And from those, this is from stateless feature perspective, regression scale testing going okay. And we have basically 90% of the issue we observe has been merged. The 10% still under reviews. From IPv6 port side, all found issues are fixed and merged. And we basically have one issue which need a verification. We will do that. Next is just ongoing testing for these 1.7.x features, which is moving forward. And we have a whole series of peer which need to be merged. and most of them comments are resolved, but they just need to be, closed. This is the GTP extension support issue we talked earlier. This is slightly slow moving. So they are the enhancements to the open source here, OBS and RYU, and so those basically we need to report those fixes we done earlier because the versions were changed. So this is reporting work going on there, and the rest is just continuous testing. So this is the status of the testing. So we discussed earlier, we have completed very much testing with the Bicep in 2 places, and the calls are working and looks like in good shape. From regression testing perspective, we are doing with the stateless feature enable, and the passing rate is 68.30% here in this case. And this is the scale test numbers. So we are continually running a longevity test for 12 G node V and 200 UVs with 5 tests per second. So we have tested actually NAT and no NAT both features. So this is very much we have. Any questions?
Any date when this 1.7 release will be officially out? It's a question that's been asked in multiple forums. I know we are continuing to test.
Yeah, I think Kader, I think the date is not published yet. So yeah, we will follow up on this.
1.7 will be most probably released next week. That's what we discussed in our last meeting.
Okay.
Oh, okay.
Right. Thanks, Shubham.
All right. Thank you.
Great. Thank you. Any questions? Okay, great. Thank you, Daji.
Yep.
Now we will go to the DevOps update. Will that be you, Shubham?
Yeah. So from DevOps side, we are right now focused on the 1.7 release. So Terraform code is finalized for the AWS deployment. And we are also building a pipeline which will automatically push the AMI images for our AWS deployment on our marketplace, AWS marketplace. And side by side, we are also building like ARM-based access gateway, Docker-based access gateway for both ARM and x86 for 1.7 release. There are few areas that we are stuck, but yeah, we are working on it. Yeah, that's it.
Great. Any questions for Shubham? No? All right.
Sorry, Kendall, it's just a continuation of what Parthiban was asking to Shubham. Shubham, maybe we can take this offline in the Slack. Maybe I'll have Suresh or someone to reach out to you. Where do we get the documentation that could allow us to deploy scalable, high available orchestrator, the architecture and the deployment scripts, as well as the A gateway side of it, right? Is this officially available and not available? That kind of know-how would be good to know. He just brought it up. I just thought, maybe this is something that we may have to sync up offline.
Yeah, sure. We can sync up offline.
Sure. I'll have Suresh to reach out to you. Thanks.
Sure. Thank you.
All right, Kader.
All right, great. I don't see Echo on the call. Would there be anyone giving a release update, or do we want to take those off of the agenda?
Just one thing.
Sure.
I have moved all our Etherpads stuff to the Confluence, so we can start using that.
Oh, fantastic. I was actually about to touch on that. So you moved all of these meeting notes to the...
Yes. I have shared
fantastic.
this on the dev channel. I have shared this link, and previous notes are there, meeting recordings are there, and I have created a template for our today's meeting. So yeah.
Great. Cool. I was actually just about to touch on that. So thank you for doing that. Yes, we're trying to migrate everything over to the Confluence, which is wiki.magma-orcer.org. So we're trying to keep everything in one spot rather than multiple different Etherpads and Google Docs and whatever have yous. So if you're looking for anything, it will most likely be in the Confluence pages. So keep the lookout as we keep migrating things over. But yeah, that brings us to the end of our agenda. Are there any other business that people would like to bring up? All right, I'll take the silence as a no. We can go ahead and end early and give you 20 minutes back in your day. Thank you, everyone.
Thank you.
Thank you.
Have a great weekend.
Thank you. You too.
Thanks. Bye.
Bye.
Thank you all. Bye.
Thank you, everyone.